Hello and welcome to the channel Understanding Concepts of Physics. So we have been solving a series of numericals of oscillations, and we are with another numerical on time period. So let's just quickly solve this. This is going to be a very short video, a very easy numerical for maybe a mark or a two. So the question is the period of oscillation of a body. Now I'll just mark it. So the period of oscillation is something we are supposed to find out for the time period is given as t for mass m1. So remember that when there is a spring which is oscillating, its time period is t when m1 is hanging on that. But when a mass of m2 is tied to the first body, that means that now the net mass is m1 plus m2. Now the time period is 2t, and they are asking what is the comparison of masses. That means they are saying that when mass m1 was hanging, the time period was t, and when both of them were hanging, the time period was 2t. So if I wish to draw a diagram, it would look something like this. Suppose if this is the mass which was hanging, let's say m1, the time period was t. But in the second case, when the same spring is used and the mass is m1 and also there is one more mass m2 hanging, then the total mass hanging from the spring is basically m1 plus m2, and that now the time period is 2t. Remember that time period does not depend on mass for a simple pendulum. It is for simple pendulum, but that does not is true. That is not true for a spring. So for spring we have a specific formula for oscillation. Now if you see, they are asking us comparison of masses, that is m1 plus m1 upon m2 is equal to question mark. So we have a very specific formula for t is equal to 2 pi root of m by k. We have this formula, t is equal to 2 pi root of m by k, and we'll make this use of this formula using for m1 and also for m2. So in my first equation the time period is t, so the 2 pi root of m1 by k, that is one formula. Now k is a specific constant for a spring constant which is fixed for a spring. So because we are not changing the spring, the value of k will not change. We cannot write k1 and k2. And then we have this 2t which is equal to 2 pi root of, now in the second case m1 plus m2 is attached and the k is same because the spring is same. So here the difference is m1 plus m2 and here there is m1. Mind you, do not put it only m2 because it's the entire load m1 plus m2. Now divide these two equation. So once you divide these two equation, what you get? You get something like this: t upon 2t is equal to 2 pi root of m1 by k, and here you will get m1 plus m2 by k. 2 pi and 2 pi gets cancelled, t and t gets cancelled, k and k will get cancelled, and root cannot get cancelled, your root will be common. So what remains is 1 upon 2 root of m1 upon m1 plus m2. Now I'll square this. So 1 square is 1 and 2 square is 4. So 1 upon 4 equal to m1 upon m1 plus m2, because when you square it, square root and square will get cancelled out. Now this, take this term on this side and take this term on this side. So you'll get m1 plus m2 ones are m1 plus m2 and 4 m1s are 4 m1. Now take this m1 terms on this side. So this plus m1 will become minus m1. So 4 m1 minus m1 will give me 3 m1. m2 remains alone. Now this m2 comes here in the denominator, so I'll get m1 upon m2. I'll get m1 upon m2, and this 3 is multiplied over here, so it will go on this side, so I'll get 1 upon 3. So ultimately I get m1 upon m2 is equal to 1 upon 3. So you see, this is a very easy numerical. You can just take a screenshot if you wish to at the end of the entire numerical, and it's a pretty easy numerical. You just have to note that in the spring you have first is m1 and then you have both the masses. Many of the students make a mistake that in the first case they put m1, in the second case they put m2, and they'll end up with some other answer. But make sure that when you are attaching a mass in below the first mass, the total mass in the spring will be m1 plus m2. That is the most common point of error. So thank you so much for watching, being with me. Subscribe the channel in case you have not done so. As it, all the best for your exams as they are approaching to as they are approaching very fast, and you might be studying a lot these days, but keep doing one at a time and keep solving past papers. Thank you so much for watching. Have a nice day. Bye.